Mr. Dornbos has been a faculty member of the Calvin Biology Department, teaching courses and mentoring graduate students since 2004. He has also worked in crop genetics and agronomy. I'm not sure I'm saying that right.
Agronomy.
Agronomy in the agricultural industry in roles such as the global head of seed production and field agronomist. He is a member of the Iowa State University graduate faculty, where he earned a PhD in crop production. He also holds an MS degree from Ohio State University, and finally a BS in biology from Calvin University. He has also authored a book entitled Your Stake in the World, on which this course is themed. So with that, one other thing I want to mention, if you have questions, Dr. Dornbos has an okay for you to just raise your hand, and instead of waiting till the end of the whole program, you can interrupt his presentation and ask questions. So with that, I'll turn the microphone and the camera over to Dr. David Dornbos, and enjoy.
Yeah, thank you. Yeah. So I'm curious, as we kind of get going here a little bit, I need to know a little bit more about you. Has anyone here worked in the health industry? Okay. Okay. MD. So several people have worked in healthcare. How many of you have farmed? Representing the corn and soybean, got it? How many garden? So I was kind of told that this was a gardening group. So I'm tickled about that because I'm an avid gardener as well. And maybe through conversation, I can pick up some new hints along the way. And you may see pictures of my garden, probably not this week, and probably not next week, but certainly the week after that. So I do want to engage the breadth of the food system. On week 2 and 3, we'll get into the food production system, which is part of the food system. And I certainly do want to link food consumed by people, its impact on human health, with food produced, its impact on environmental health. With the idea of painting a picture in your mind about a food future that I'm thinking about and would love to see, I guess, culture more broadly engage. And so kind of with that, a little bit about my background. This is the book, Your Stake in the World, developed from teaching this course over a period of years and not finding any kind of textbook, reading lots and lots of papers and Scientific American articles and kind of cobbling them together. So I had students at one point in a semester course reading on the range of like 400 to 600 pages. And so what Your Stake in the World is attempting to do is bring these two kind of human health and environmental health components together. Hope, like Calvin, has a large contingent of biology students every year coming in, many of whom are thinking about healthcare industry. And yet in the biology department, we typically have the healthcare side, and we also have an environmental health or environmental sciences side. And those two cohorts of students seldom, in my history at Calvin, and I think it's true here too, seldom talk to one another. And so part of the idea of this course was to bridge that gap. So my background is Calvin, Ohio State. I saw a Michigan hat back there. The Iowa State, yeah, I know. Fortunately, there's a next season, but we'll see how it goes. And a PhD at Iowa State, if that helps a little bit. And I currently teach on the graduate faculty for Iowa State. So that's where the grad student mentoring comes from. I was involved in ag industry. Syngenta is the company, life sciences company that I work for. for about 15 years. So I was a field agronomist in Southern Illinois, Kentucky, Southwest Indiana, and the state of North Carolina, kind of oddly, for about 2.5 years, and then found myself directing the product development group. So this is the kind of the arm of a seed production, like an agricultural seed production company that does the on-farm testing of advanced experimental corn hybrid soybean varieties, on-farm testing. So we were involved as a group with bringing BT to the marketplace, doing the first field testing of the GMOs that came along as well. So that's a little bit of my history. Some of that will play out in here a little bit. And you can certainly ask more questions about that if you wish. The last 7 years that I was with Syngenta, I did a switch from the research and marketing side to the production of seed side. So I moved to supply management. I had a global job there for about 7 years. Really, the focus is on producing corn hybrids, where you have 2 inbred lines, and to get them to cross-pollinate effectively turns out to be, there's a lot of interesting science there. I felt pretty strongly called to leave ag industry and go to Calvin. So I've been at Calvin now 21 years. I taught half-time last year, and I'm going to teach half-time this year, coming year. And then I'm probably done, other than maybe adjuncting a course here or there, just because it's fun. And it keeps structure in life, which is also, I think, important. And really, kind of the theme is relationship then between food production systems and environmental sustainability. So I've been passionate about environmental sustainability. And I was passionate about environmental sustainability when I was a student at Calvin, while I was working in ag industry. An interesting thing, though, when you're working in agriculture, you don't think about farm fields as being ecosystems. That was a novel idea to me, like my 6th or 7th year after coming back to Calvin as a faculty member. First, and I'll share that story a little bit more. I think that's an important idea here, that an agricultural field is an ecosystem, and it interacts with all natural ecosystems. So, oops, overshot there a bit. So this is kind of the thesis of the course in the book as well. And it's the idea of economics and ethics, week 4, promote, or could be thought about or used to promote the adoption of an agroecological food production system with the idea of improving both environmental and human health at the same time. So I think this is the link where these come together. So what we're going to do is week 1 today, we're going to talk about how food system impacts human health. So this may be a bit trite to some of us who worked in healthcare. Maybe not, I don't know. That's obviously not my background, right? Next week, we'll talk about the food system impact on environmental health, particularly what agro fields are doing to native ecosystems. And then week 3 is to reconcile. It's a faith-based word. So sometimes people talk about restore. I'd like to use the word reconcile food production process and introduce this term agroecology. If I throw the word out agroecology right now, is it a new word to you, or is it something you've heard of? You know it? Yeah. Most people, it's kind of new. Okay, good. So I'm going to make you feel pretty bad about our food production system on week 2. Week 3 is maybe will be a bit of a breath of fresh air. At least it was for me as I kind of my walk in figuring this stuff out. So I was feeling really, really bad about my profession kind of at that point, or aspects of it, I should say. And then the week 4, I think, is important because the question is, if we're going to drive cultural change in how people consume, in what food we produce for people to consume, I think we have to have win-wins in place for the consumer where they're going to want to do something differently. And I think there are win-wins to offer. So that's where we're going to go on week 4. So the food system, I want you to think very broadly about the food system. And what I want you to think a little bit about is food systems are complex, they're economically significant, they're poorly understood, they're very impactful on health, biologically unsustainable, at least in terms of how it relates to how we produce food in bulk today. And it's multifaceted. So we have consumers here, we have farm fields there, we've got farmers up here, there's lots of inputs, sunlight, water, energy. There's an economic system that affects a lot of how farmers produce what they produce and how they produce it. Of course, consumers over here are the ones that are really, in some ways, driving that. So farmers produce what consumers want to buy to eat. So there's a system, and there are multiple feedback loops. Politics are involved. The Farm Bill is definitely a political instrument. There are social system impacts. We can start thinking about justice issues related to food supply and what food people really have access to. And then there are biological systems. So these all interact. It's a very complex system. So if you've thought about systems and system function, you realize if you make one small change to a system, you may or may not get the feedbacks that you expect. And I think that's certainly true in this kind of system. Okay, go forward. Oop, that's not what I wanted to do. Page that one. So when faced with ideas inconsistent with your current beliefs about food systems in this case, who should you believe? Let's just say I share some ideas and they're not consistent with what you thought. How do you know if you should believe me? You can go online, and I would advocate that. But how do you know with what you're getting online if it's good information or not? So what I want to do is kind of start by introducing the co-author to the book. So I'm going to talk about food consumed on human health. That's where we're going to focus today. And I'm not qualified to talk about that with any kind of authority at all. So it was Dr. Jay Hallman, who turns out to be an interventional cardiologist. He is now retired from LSU, but he was the director of cardiology at the Cleveland Clinic for about 15 years. And so he actually had started this book, Your Stake in the World, and he had written a number of chapters on the impact of food consumed on human health. Chronic disease is really where the focus is here. And we met at a conference, an ASA conference, which is kind of a conference where scientists who are Christians get together. And I hadn't met him before. And I was giving a talk about the impact of agroecosystems on natural ecosystems. ASA, Affiliated Scientists of America. Yeah, not American Society of Agronomy, if that's what you're thinking. Which I had gone to for years and years and years, and I realized there's a whole nother ASA out there. Yeah, there are. And so I had given this talk, and he approached me after the talk, and he said, I'm working on a book. What I don't have is anybody with agricultural insight, in agricultural history, background. And so that's where we started the conversation that ultimately resulted in that book. I talked about the Biology 364 course, Global Health, Environment, Sustainability, and what I was trying to do there. And I realized I was kind of dabbling around in the impact of food consumed on human health, and now I had an authority. So he could answer a whole lot of the questions that I had. And ultimately, we wrote this book together. So the book is this, Your Stake in the World, kind of a snarky title. It's more of a textbooky kind of book, a lot more textbooky than we intended. Some of where my background had been is I was aware of Colin Campbell. Have any of you read the China Study, the book? I would advocate that you take a look at the book. It's been around a few years now. You can get it very inexpensively. So Colin Campbell is a PhD guy at Cornell, now retired. And he wrote the China study. And then Caldwell Esselstyn is an MD that worked at the Cleveland Clinic with Jay Holman. And so they developed kind of two documentaries over the years. Forks Over Knives has been around a little while. Has anybody seen it? Yeah. Okay. And then Plant Pure Nation a bit more recently. So you have to pay a little bit to watch Forks Over Knives, but Plant Pure Nation is free. And so I would advocate, actually, if you want to, watch that little documentary film between now and next time. So as you think about ideas that you might get that are kind of unique to you, what I would kind of advocate is kind of what I advocate to my students is how do you interpret evidence? So it was always a little bit, it is a little bit frustrating to me when I hear people say, follow the data. So yeah, the data is important, but no one's going to look at a spreadsheet without someone interpreting that. So it's actually the interpretation of the evidence that's critically important. And how do you know if you're getting an interpretation of evidence that's reasonable or not? And so there are a couple of ways of thinking about this. One is think about the source, at least this is how I do it. I think about the source. Where am I getting the information from? Is the person an authority? Well, I think Holman is a reasonable authority as it relates to diet and cardiac health. And so that's who I'm leaning on today. And then the second question is are there conflicts of interest? In other words, is the author that's maybe an authority on a subject, do they have money at stake, if you will, or power or prestige or something at stake? And so you're hoping to be able to say they're an authority and that you would hope to say that they have no conflicts of interest. And then the kind of the third one, which I think is really the linchpin, is where is the preponderance of evidence? If you look at multiple sources of information, do they line up and have a common theme? So I think we're looking for authorities on topics without conflicts of interest, whose ideas at least mostly align with other authorities that also have few conflicts of interest. So that's kind of the source of the information. The other idea then to think about is, what is the evidence type itself? So there are case studies. Case studies turn out to probably have the least predictability. I don't know about you, but I had an uncle, Harm, who was a lifelong smoker, and he lived till age 92. So is that good evidence that smoking is not harmful to your longevity? I mean, probably not. It worked out for my uncle Harm, and he smoked a pipe. I don't know if that makes a difference. Probably not. So anecdotes or individual case studies that turns out to the general public are really very compelling, because how would you not like my uncle Harm? But there turns out, in terms of, even though his history is accurate, how predictive is that for other people? It turns out not very much. So observational studies are kind of a more useful source of evidence. The idea of observational studies are we're going to look at cohorts of people, and we're going to say there's a relationship. More people who smoke get lung cancer or heart disease. And we can correlate those. But the idea of correlation is a little bit lacking. A correlation implies there's a relationship, but it does not imply causation. So if you don't know the cause, you can have lots of things correlated, but they're actually unrelated because there are other factors related that you might not necessarily see or have tested in the correlation. So useful, especially in big studies, but not super helpful. I'm going to show you a bunch of data a little bit later on where we're going to look at population studies, both retrospective and prospective. Retrospective is you look at people who maybe have eaten a certain diet for 10 years, and then they recollect what they ate and report it, and then you look at maybe their healthcare history 10 years affected by prior by what they ate. So that's a retrospective cohort. A prospective cohort's a bit more powerful because people's memories aren't necessarily all that good. If you do a prospective cohort, that's to say, let's all sign up. If you all sign up, track what you eat for 10 years, and then what we'll look at is incidence of heart attacks or strokes, that sort of thing. And then we'll draw the relationships based on that. So it's a bit more accurate, but you got to set up for prospective cohorts in advance. And when we're talking about something like chronic disease, which is kind of where we're going, you're talking about disease outcomes or patients that are presenting after having lived a certain lifestyle for a really long period of time. And so it's kind of hard to know where did that chronic disease come from necessarily. There are randomized control studies. Oh, shoot, I did it again. There are randomized control studies, which we won't talk too much about, although I'm going to give you one shortly, I guess. The gold standards are meta-analyses and synthesis reports. So meta-analyses are multiple randomized control studies that are combined. The data sets are combined. So they kind of almost by definition have some preponderance of evidence in them. And then a synthesis report would be a report from like an expert panel. So like the National Institutes of Health, for example, would be an example of an expert panel. So how does the food we consume impact human health? So this is where you got to play back to me a little bit. You die without it, so we have to eat. Let's establish that. I did have something to eat before I left Kentwood to come here. Yep, so you hit a kind of the standard American diet. The acronym is SAD. We're going to talk a lot about the standard American diet. And then you said is related to yep, heart disease. Yep, okay. Weight. Yeah. Optimal functioning, sure. Quality of life. We can refer to quality of life in a lot of different ways. I'm going to introduce the concept of dailies, daily adjusted life years. So these are life years that you can actively function, move around, and maybe enjoy life. So yeah, critically important. There are QALYs too, sometimes people talk about, which are quality adjusted life years. What in diet do you think is are there smoking guns in diet that you could point to or that come to your mind? So red meat could be there. So that's where the little snarky title comes from, your steak in the world. Does it mean you should eat no red meat? Sugar, certainly part of it. Alcohol is certainly part of it. Say it again. Fried foods. Yeah, so what is it about frying food? You're frying you could fry in lard, which is animal fat. You could also fry in vegetable oil. So vegetable oils are generally considered the more healthful oils. And yeah, a third of the calories you consume should be fat. Well, there's acrylamide, so these are byproducts of frying, which have some concerns. Processed foods. What is it about processed foods? So there could be preservatives involved. How many of you read Michael Pollan's In Defense of Food? Yeah, do you know Michael Pollan's little thing? If there are more than, I think it's 5 ingredients on the ingredient label, it's not food. Yeah. Yeah, okay. I haven't read it. I'd like to read it. So we're going to build on some of these ideas. Here's health in the United States. How are we doing in the United States compared with other developed countries? Maybe you've seen some of these statistics. This is a little bit old, but this is one of the graphics that really caught my attention about 15 years 15 years ago or so. And you can see we've got average life expectancy as bars. Now, a word of caution, this is going from 74 to 82, not 0. So when you tighten that scale, it makes the difference between bars look big. So the skeptic in you should say, but look at the y-axis, okay. On the x-axis, we've got Japan, Switzerland, Austria, Sweden, here's Canada. And so if we look at Canada, life expectancy about 80, we go to Japan, 81 and a half. The red line is the per capita spending cost. And the per capita spending cost tracks along with essentially longevity or life expectancy. So what catches your eye? The United States' life expectancy is like 77 and a half. And there could be a lot of reasons for that. But look at the healthcare cost. So it feels like we're paying a lot and maybe not getting a great value for your money. That's just life expectancy. We can look at infant mortality. It's another kind of metric that people who watch effectiveness of healthcare systems or healthfulness of the public take a look at, and they can say, okay, here's these same countries as bubbles. And we can see up here, we've got Poland, Hungary. They're very low cost healthcare systems, as opposed to maybe Norway is pretty high cost healthcare system. Iceland is a bit intermediate. And then the line is kind of essentially a linear regression between these bubbles. And we see, okay, we've got Austria with a relatively moderate kind of death per 1,000 live births. Iceland, they're paying a lot of money, but their deaths per live birth are really low. So it feels like that's working. And then the United States is sitting out here. We spend a lot of money in healthcare, but in terms of live births, not great. Especially if we talk about a lot of this is nested in the African American communities, for example. So those are kind of two broad metrics that caught my attention, going like, we're spending a lot of money in healthcare. Why aren't we seeing better outcomes? Seems like we should see better outcomes. So healthcare cost of the US lifestyle, this is coming from the CDC. And so these are more recent numbers and I think a bit more accurate. I'm trying to put some financial numbers on it to give kind of the scope of this. The US healthcare spend in 2023 was $4.9 trillion. And that was a 7.5% increase over 2022. So if you're investing your 401k stocks in healthcare, it's a good place to be because there's more market growth in that sector than most other sectors in the US economy. So $4.9 trillion is a chunk of change, right? 86% of that spend, according to the CDC, is for chronic disease. So think about chronic disease for just a second. Boils down to just a little under $13,000 per person per year, plus your healthcare insurance premiums, which are average around $8,900. So for a family of two, healthcare costs is in the range of $34,000-ish. So we spend a lot of money on healthcare. If we eat a healthier diet, what would the implications be on food system costs? So here's the thing about chronic disease. Here they are. This is a chart from the CDC. This was a chart they had in 2020. I haven't seen it lately. But if we look kind of up here, we say, okay, 6 in 10 adults in the United States have a chronic disease. 60% of US adults. 4 in 10, 40% of adults in the United States have 2 or more chronic diseases at the same time, comorbidities. And so what we're talking about are heart disease, cancer, chronic lung disease, COPD, stroke, Alzheimer's, diabetes, and kidney disease. Those are all a range of chronic diseases. So how do we deal with those chronic diseases? So I don't want to cast aspersions on our healthcare system necessarily, because our ability to deal with acute care is phenomenal. But chronic diseases, most of that spend is to deal with the symptoms of the disease. They're not to deal with the cause of the disease. And doctors are not maybe in a place where they are in a position that they can do anything as it relates to the cause of chronic disease. Our number one go-to is pharmaceuticals. And so there's kind of two components to each bar. There's the government cost, if you will, and then the voluntary individual's cost. But bottom line, in the United States, again, I'm comparing with all the OECD countries, we spend a ton of money on pharmaceuticals. And you saw the outcomes more broadly, and you probably know them personally as well. So we're dealing with the symptoms of chronic disease. When you take insulin, when you take statins, when you take a lot of these drugs, you're not ever dealing with the cause of the disease. In fact, you're really destined to take those same drugs lifelong. So there are a lot of snarky things that could be said, but on the other hand, statins definitely do work. I mean, they do what they're supposed to do. If a chronic disease presents, if we look at high cholesterol, stroke, blocked coronary arteries, systemic vascular disease, or cancer, the standard of care is typically a statin drug in the case of high cholesterol. In the case of a stroke, it's blood thinners, Coumadin being just one example. In the case of coronary, vascular disease, specifically coronary disease, angioplasty, a stent, arterial bypass. Those are, again, they feel like you're solving the problem, and in a way you are, but it's systemic vascular disease that has caused that. So if you put in a stent, there's no guarantee you will never need another stent. In fact, if other things don't change, like lifestyle, diet and exercise, you probably will need more. Or cancer, chemotherapy, certainly radiation, surgical interventions. So it turns out these therapies treat symptoms of disease, and they're driving a lot of those costs and not the disease itself. So lifelong treatment is required and little hope of a cure. So if you watch Forks Over Knives, I guess the narrator gets really snarky at some point in time and says what pharmaceutical companies really want are people sick enough to need their pharmaceutical drugs, but not so sick as to die, because it maintains a revenue stream then for the company. And so I'm sure not everybody in those companies think that way, but it sometimes feels a little bit like that. So the question is, what is driving, what is causing this incidence of chronic disease to the point where 4 out of 10 Americans have one, and 6 out of 10 have one, and 4 out of 10 have 2 or more? So the role of diet to prevent and occasionally reverse disease. This is a randomized control study. It was done by Esselstyn in 2001, and it makes a point. It's entitled "Resolving the Coronary Artery Disease Epidemic Through the Plant-Based Nutrition." It was published in Preventive Cardiology. I can give you the article if you want to see it at some point in time. What Esselstyn did is he signed up 26 individuals initially. There were not 18. 26 signed up for the study. 8 of them did not stay on the dietary plan, and so they were removed from the study. The 18 individuals that did sign up for the study and stayed on the plan prior to the study starting had a sum or total of 49 heart attacks. And the reason they went into this plan, which would otherwise be unethical, is because they were considered terminal. They were no longer eligible for bypasses or stents. So there was no other chance for them. So what Esselstyn did is he gave them an aggressive plant-based diet. In fact, he would take them to his house and he would show them how to cook meals, which were largely vegan meals. And it was a very aggressive, what I would call a very aggressive plant-based diet. In 12 years later, all 18 were alive. They had all outlived their terminal. They were all given less than 5 years to live. They were all alive after 12 years, and there were no new heart attacks. All achieved cholesterol targets below 150 milligrams per deciliter of blood. 75% of the patients actually had regression in their heart disease. Now, not all did plant-based diet only. Some used plant-based diet and statins, so that part was a mixed bag. But probably the poster child in the paper anyway is kind of that image. So this is the image of the artery of one of Esselstyn's colleagues, another cardiac surgeon who had at age 49, a heart attack. And this was the disease part of one of his coronary arteries. And then after 32 months of a plant-based diet without cholesterol lowering medication, so without statins, diet alone, that's the artery. So which artery would you rather have? So this is a case, it's not going to work with everyone, but it is a case where a diet mediated therapy actually reversed the disease. Similar results happen in cases with diabetes 2, not diabetes 1, but diabetes 2. So how have we been culturally conditioned to think about disease? So I'm going to play a little game with you. Common chronic diseases. You're going to say, yes, it is disease or not. So I'll give you a list. So here's the first one. Coronary infarction. Would you consider a heart attack to be a chronic disease? You probably could. How about vascular plaques? Is that considered disease? Sure. High cholesterol? Mostly? Okay. How about high blood pressure? Yeah, the next one's going to put you on the edge a little bit more. How about obesity? Are you willing to think about obesity as being a disease? I'm not sure I am. I'm not sure I am, but it turns out I've got a son who works in pharmaceutical discovery, genetic based for Regeneron, and he kind of confirms obesity is the bellwether for just about everything that could go wrong. So I want to throw a definition of disease at you with kind of the topics that I just give you, let them linger in your memory for a second. So disease is, I'm going to say, a condition that makes your life shorter and less fulfilling. So I'm interested in those quality adjusted life years I think someone mentioned. Disease-related terms, we can talk about infection rate. We're going to talk about incidence, and we could talk about incidence and we can talk about prevalence. Incidence is the number of new cases in some time frame. Prevalence is a number. They're going to be numbers that relate to how many ongoing cases there are, not just the addition of the new ones. So it's the addition of the new ones plus the cases that haven't been resolved. So that's prevalence. We're going to focus on prevalence of chronic disease. So mortality is death rate. Morbidity, so I think you're familiar with that. Morbidity is, you could relate that to quality of life. So this is where the disability adjusted life years come into play. or the quality adjusted life years come into play. These adjust for the years that you might be alive, but you really can't function in the ways that you might want to function. And then comorbidities, if there's simply more than one of the diseases, if you will. So hypertension, atherosclerosis, high or low BMI, maybe cholesterol. So the question is obesity a disease? And I'm not comfortable calling it a disease, but it certainly is an indicator. It is a prime indicator of what healthcare practitioners will more often use the term metabolic disease. And so metabolic disease is kind of, I know this is a term that at least Hallman introduced me to. Metabolic disease is kind of this suite of things. When you start seeing a patient present with high blood pressure, high heart rate, high cholesterol, those are the presence of all of those factors together indicate that something metabolically is not right. And so metabolic disease turns out better than obesity to be an excellent predictor of type 2 diabetes, coronary heart disease, stroke, aneurysms, and many cancers. Actually, probably most cancers. So obesity. We're going to go there because turns out it is a good indicator. So let's look at the standard American diet and obesity. Obesity first. The most commonly used obesity estimation, you're probably familiar with this, is body mass index. It's also deeply flawed. It's not a great measure. There are lots of people who would indicate have high BMIs and they're not obese at all. They're just muscular. We used to call them mesomorphs. But the thing is all you need to calculate a BMI is weight and height. So you can very easily calculate the BMI of the entire American population at any point in time, for the most part. And you can track it over time. So people use BMI a lot, even though it is not certainly the most precise measurement. If you get the most precise measurement, you got to float yourself in a tank and measure displacement versus mass. That's where you get that. But it's hard to get everybody to float in a tank, in the right tank anyway. Well, the pools sound really good right now. So basically this is, the top line, that thing keeps falling off me here. I hope people out there can hear me okay, because I think I'm fading in and out on this thing a little bit. So the top line is weight. And so this is my BMI. My weight is right around 162. And my height in meters per meter squared is 1.7, I think that is. Can't hardly see that on my screen up here. So my BMI calculates out to be about 24.8. I am on just the high side of what's considered normal. So underweight would be here if you have BMIs that are too low for height, considering the weight-height combination. Overweight's here, and then obese is out here. So yeah, I'm on the high side of normal. I sit right at 25. Thing to know about BMI is it has what's called a hormesis effect. This is kind of like a Goldilocks effect in that you can have BMIs that are too low to be healthy, underweight. There is a Goldilocks zone. The porridge is just about the right temperature. And there are BMIs that are too high and become unhealthy as you move out to higher BMI. So as BMI moves from 15 out to 50, you can see the risk of disease off a baseline of 1, no risk of disease. It goes up if your BMI is too low, and it goes up if your BMI is too high. So how has the prevalence of BMI changed in the United States? Yes. Yes, thank you. What happens, how about the BMIs of athletes that are really thin and have BMIs that are single digit like or really, really low? I don't know. As an athlete, you might have to carry a BMI that low to, say, run a marathon effectively, but longer term health impacts, I'm not sure that is entirely healthy. That being said, there's always going to be variability. You can kind of even see within the normal BMI range, BMIs are definitely risk of disease is going up if you get into that lower end of the range. And so, maybe for a period of 5 or 10 years when you're athletically doing the things that you need to do, and the BMI is okay, but maybe not lifelong. Same could be true with something like football. Football players, you look at your U of M players, those linemen or running backs, they're going to have BMIs that are going to be up there. They're heavily muscled, but when they often stop playing football, they lose that weight, and they can lose that weight sometimes pretty fast, which kind of boggles my mind because I haven't been able to change my weight most of my life. I tried to lift weights and build muscles and impress the girls, and I lifted more weight and the muscles didn't change, but I've been happily married a long time. So I don't know. I've wondered that though too. Prevalence, how has it changed? Thumbs up. Okay. Do you know how much it's changed? A lot. Okay. Do you know how the dynamics have changed over maybe a period of a couple of decades? So I think when you start realizing that if you go back into the 1980s, even 90s, there was some chronic disease, but not nearly the level of incidence as there is now. And so I think there's some charts here by the CDC that are really, really helpful. And this is why there are so many slides in the PowerPoint. So we're going to zip through years. We're going to zip through them pretty fast. And so let me just kind of show you what's going on here first, and then I'm going to zip through them. So there's a scale on the bottom. There's no data is white. This is obesity trends. This is the BMIs greater than 30. And so if the incidence of BMIs greater than 30 is less than 10%, you get light blue. Then you can see if you get up to red, it's going to be equal to or greater than 35% of the American population has got a BMI of 30 or higher. What I'm going to tell you is about halfway through this slide set, there's going to be a new scale in a color scheme change. And that ought to frighten you, or at least give you some pause. So I'm going to go kind of fast. We're going to just give each one of these like 10 seconds. And I'll kind of highlight as we go through, because we're starting in 1985, right? And we're going to go to like 2023, which is I think the last chart that was out. And so if you look at 86, 85, not a lot changed. 87, you see we filled in some more dark blue, that blue right there. And then 88, we picked up a little bit more. 89, a little bit more. There's some states kind of moving around. So we're getting kind of more states. Now here in 91, we started picking up the 15 to 19% range. Look at where those states are. Note where those states are, because there's going to be a theme here. And you go to 92, and then 93, and then 94. See where they're filling in? So where the light blue filled in earlier, 95, 96. So we're still mostly in that 15 to 19% range, 97. Now we start picking up yellow. We're in the 20 to 24%. Now look where those states are. 99. That was a big change that particular year. And then we go to year 2000. We've got a lot of in that 20 to 24% range. And then 2001, we picked up 20 to 25%. Notice where they are. And then 2002, 2003, 2004, 2005, and then we, like 3 years after we picked up orange, we started picking up greater than 25%. What's in the water in Colorado? Something weird in Colorado. It turns out it's persistent. 2006, 2007, 2008, 2009, 2010, in 2011. So roughly 15 years ago, the CDC had to change their scale, and look what they did. They now carry it out to much higher levels. So we're out, it was greater than 35%. Oops, shoot. Well, 2000. Trying to pinch that on my ear. If I look here, maybe that's better. So 2009, we're got a set of populations, Mississippi above 30%. There's 2010, 2011, we do the scale switch. So now we're going all the way up to 50% of the population or higher on the outside of the scale. And so if we keep going, 2012, 2013, look at where those states are, 2014, 2015, 2016. So those southern states are 40 to 45%. 2017, 2018, 2019. Now we're starting to pick up the next color. 2020, 2021, 2022, 2023. And that's my last one. What did you notice? Themes. Yeah, what's in the water in Colorado? It's a lifestyle. Okay. Yeah. Yep. Yep. A lot of people have migrated into that eastern, kind of that front range, I guess it is. Yep. What else? What else did you notice? What's that? They definitely follow a pattern. Let's talk about the pattern. What do you notice? East of the Rockies is not as good as west of the Rockies. Where east of the Rockies are the concerns the greatest? It's the Farm Belt, with actually the Mid-South actually leading the charge. So you look at Mississippi, Louisiana, Alabama. My son is now working for the University of Kentucky, and he's an endovascular neurosurgeon. I think he's going to stay plenty busy. Okay. So that's a little snarky, but it paints a picture, I guess. Did you notice something about the pace of change? It got faster, and I'm not sure it's still as fast as it was increasing before, but from about 2015 and on, and maybe even 2010, it seemed like the pace that obesity increased definitely increased. So Google gives you lots of advice about diet and health. So I'm going to play with you a little bit here. If you type in meat and say, Google, paint a word picture, or a word map, this is what I got. And so beef, pork, chicken. And if I ask Google vegan, you get this kind of a food map. So the question is, should we eat meat? Should we eat certain kinds of meat? Should we eat no meat? Do we all need to be vegan? Or is vegetarian enough? What does the evidence actually say? Which is chicken? Maybe if you eat meat, but just chicken or fish. Or do we need to be a vegetarian? Or do we need to be a vegan to protect health, prevent the risk, or reduce significantly the risk of chronic disease? So here's what the numbers actually show. This is from the ERS. This is part of the USDA. And they report what people eat because the USDA wants to promote the kinds of the production to reduce the production costs and assure that there will be a steady food supply. And so it turns out plant food. Oh. Plant food's about 12%. but notice only of the plant food, only 6% or so is veggies, fruits, legumes, nuts and seeds, whole grains. This darker green are the fruits in processed foods. So healthy choice meals. I'll pick on ConAgra a little bit. Animal food, 25% of the percent of calories that we eat is animal food. I'll note that animal-based products have cholesterol in them. Plants do not make any cholesterol ever. So if you're eating plant-based foods, you will have no cholesterol in your diet. Processed foods are 63% of the percent of calories consumed. Standard American diet. So is meat to blame? Well, what does the evidence of large cohort studies say? So this was the prime question. So how much meat do we actually eat in the United States? Well, the average total meat consumption is 128 grams per day, which boils down to, sorry for the pun, 4.5% or 44.5 ounces, which is slightly more than 1 quarter pounder hamburger patty, if that helps you visualize what is what. Red meat, of that total, red meat in the United States is about 60% of it. So of the total 128 grams per day of meat that we eat, 58% of it is typically red meat. So in the United States, we do like our red meat, but it's not the only meat we eat. So I want to give you the takeaways of the cohort study before I actually give you the cohort studies, because it's easy to get lost in all the charts. And then we're going to dig into the standard American diet, what actually people are eating in the United States relative to what maybe might be recommended. So the big takeaways is focused on red meat and processed meat. If you look at 10-year timeframes, which are most of what the cohort studies did, mortality is about somewhere 30 to 40% higher. And there are roughly 30% higher chronic disease related to red meat consumption. Colon and rectal cancer, about a third of it is related to meat consumption. Macular degeneration, 47%. Gaining weight, accumulating up to 5 BMI units is related to red meat and processed meat consumption. Hypertension at 60%, diabetes a little less than a third, and probably some cognitive decline. Like you said, the jury is very much out on that. So when you start looking at cohort studies, these are the charts that you start to see. So this is an NIH AARP study. And this is the results of 322,000 men after 10 years. This was a retrospective cohort, is what it was. Well, what do you take away? Well, each bar is 20% of the population. So arbitrarily, of the 100% of the men in the population, you went 20, 40, 60, 80, 100. That's how they got the bars. They just divided them that way. And what they show is death by quintal. And so death by quintal is 6,000 out of 322,000. So the highest 20% of meat consumers, these guys right here, this highest fifth, they were eating 4.6 ounces per day, really at the US average. It was 3.7% of the participants in the overall study. They were 2 times more likely to die after 10 years than the lowest end, 20%. If they ate more white meat, it actually reversed that trend. So what's deceiving? I said it's on the top. This is a deceiving chart. It says processed meat, but that's not what I was thinking of being deceiving. Say it again. Yeah, sort of. So here's the thing. The highest meat consumers are often the ones that smoke, have higher BMIs, consume more daily calories, had higher fat intake, less education, lower fruit and vegetable consumption, and less physically active. So this is the concern of these kinds of studies, right? There are lots and lots of confounding factors separating those bars. So there's probably an effective meat, but you can't know for sure if there is, and if it is it that big of an effect? So the scary chart, if you don't understand that there are confounders there, well, the chart, if you don't understand the confounders there, can be kind of scary. So there are also positive correlations with eating more meat, more processed meat, particularly if you're married and white Caucasian. So what do you do with that, right? So it turns out statistically, when you have big studies like this, where there's 322,000, there are methods that people can use to cancel out the effective confounders. And so this is a risk of mortality then study that I can probably do it this way. That shows that if you eat red, this is after being corrected for confounders. So all those confounding factors that I talked about, positive and negative, red meat overall mortality for men is about 31% higher than the norm, because the lower number in the brackets is greater than 1. That's a statistically significant risk ratio. For women, it's 36% higher. Processed meat overall mortality is about 16% higher for men, 25% higher for women. Cancer risk, 22% higher for men, 20% higher for men. The small differences probably could all account for just general variability. Red meat, processed meat are pretty much separated out here. Cardiovascular deaths, 27% higher for men, 50% higher for women. So the risk ratio interpretation, overall, men are about a 31% higher risk of mortality, women 36%. That's one study. It's a big one. And that's a United States study, AARP. So you can look at health professional and nurses' health studies. These are two different studies. We'll focus on the nurses study, which is ongoing. And of the overall nurses study, they pulled out the 84,136 women who started at between the ages of 31 to 55, and then they did a 4-year check every year for 26 years, and it's ongoing. So it's still going. And what they show is that the nurses study is the bottom one. This is the starting point. This is a prospective cohort. Total, if there's one serving of meat, there's slightly elevated risk, maybe, given that lower confidence interval. 2 servings of meat per day, it's a little higher. If you get out to 2.5 or 3.5 servings per day, which is a little higher than the norm for the US population, then you're looking at about a 30% increase, which lines up pretty closely to the AARP study. There's a health professionals follow-up study, which shows essentially the same thing. Essentially, the high health professionals follow-up study showed on average a 50% increase, and the nurses' health study a 30% increase. So broadly similar to the AARP study. You can look at a meta-analysis. There are eight papers that were pulled out by the authors of this particular study, published in the American Journal of Epidemiology, and they found both processed and red meat drive mortality. The risk ratios for 75 grams of meat per day, which is the US average, was 57% higher risk of, in this case, it was mortality, although it's just showing relative risk on that y-axis. And red meat was 43% higher than the average. So why the difference between red and processed meat? We'll talk about that in a second, maybe, but there's a mixed bag on how those results have come out. There is another kind of pretty good sized study. 521,000 people were in this study. This is the EPIC study. So this was a European group, 39 to 69 years old. They tracked for 4.8 years. The endpoints are not mortality in this case. The endpoints are colon and rectal cancer, but they show some similar effects and some slightly different effects. If I do this, then it goes on both. Oh, you can't see my mouse. Okay, never mind. I'll do it this way then. These are hard to kind of understand. So red and process. Oops. The red and processed meat shows up on the x-axis. So if a person is eating little red and processed meat, there's a risk ratio of 1. And then if you eat a medium amount of red or processed meat, it's up 20%, high was up 12%. If you look at this next axis over, what we're comparing with is fish consumption. So if people eat low red and processed meat and essentially no fish, there's a 28% increase. If they eat a medium amount of fish, sorry, that's medium amount of fish, no red or processed meat. Medium amount of fish, yeah, 33%, then it kind of goes up from there. So the scale back here is backwards, and I'm just getting myself caught up with it too. Yeah, there's low, medium, and high. So the low fish bars are in the back, and the high fish consumption bars are in the front. Yes. I'm sure that is probably not in this study, although this is a European study. So I'm assuming maybe they have used PFAS and those things in Europe too. So I'm assuming that's probably background noise. Yeah. So if there's medium fish consumption, then you can see it's 28%, 33%, 56%. If there's high fish consumption, it's 20%, 12%. Kind of the bottom line is if you eat a lot of fish, it has a canceling effect on the meat consumption effect, red meat consumption effect. And something similar happens with fiber. If you look at fiber consumption in low, medium, high red meat consumption, low fiber consumption is associated with relatively high incidence of colon and rectal cancer. If you eat medium fiber, you lose some of that protective effect. And if you eat a high fiber, or you gain some protective effect. If you eat a high fiber diet, it's almost as if red meat consumption and processed meat consumption is like almost no negative effect on colon and rectal cancer only. So the top figure is eating more fish reduces the risk of colon rectal cancer. And the bottom figure is if you eat more fiber, you reduce the risk of colon rectal cancer. If you kind of think about it, if people are eating a lot of meat, they're probably not eating the fruits and vegetables. And so they're not getting the fiber. So there's probably something like that kind of going on in the EPIC study. Broadly, the data kind of lines up with where the US data is. So processed meat, I'm going to skip this. Basically, it probably boils down to salt. 33% of Americans were hypertensive in 2011. It's actually probably not salt per se, it's specifically sodium chloride as opposed to potassium chloride. So you can salt your food with potassium chloride too and get some of the effective salt and avoid sodium completely. Vegetarian and vegan diets. Which vegetarian dietary pattern is most advantageous in reducing ischemic heart mortality is the endpoint here. And you can kind of see semi-vegetarian gives a 20% reduction. Not eating any meat, a 26% reduction. Lacto-ovo gave a 34% reduction. Pesco-ovo, 34% reduction in ischemic heart disease mortality. So this is kind of maybe a little bit surprising, but if you're true vegan, they're eating no meat or no animal-based products at all, 26%, but there may be maybe at least okay to consume some eggs and some fish and some milk. And if you look at Seventh-day Adventists who don't eat meat, you see the same sort of thing. BMI for a non-vegetarian averages 28. Remember, 25 was upper level of what was considered normal. So there's some obesity there. Semi-vegetarian, 27. Pesco ovo, 25. And vegan, 23. So yeah, people who consume vegan diets tend to carry lower BMIs. Then you can look at diabetes and hypertension. You see as you move from non-vegetarian to semi, pesco, lacto ovo, and vegan, there is a gradual reduction in the risk of diabetes and hypertension both, by a lot. So there certainly are advantages for vegan vegetarian diets, but the question is some meat consumption okay? So here's what I would offer via Jay Holman is a prudent dietary pattern. And I'm grabbing this from essentially USDA is where this comes from. This is kind of the healthy eating plate. And just look broadly, half vegetables and fruits, big chunk of whole grains, and healthy protein. So think of roughly that being quarters as opposed to the standard American diet. So the prudent dietary pattern is focused on high intake of vegetables, fruit, legumes, specifically whole grains and seafood. It is calorically poor, nutritionally rich. And I get those phrases in your head. The idea of a pattern is that it's usually distasteful long-term to be on a diet. So what the idea of a pattern is, this becomes a normed way of eating. It's the pattern of how you just normally eat, as opposed to going on a diet, which almost implies that you're going to go off the diet at some point. So the idea of the pattern is that you adjust eating patterns to become a lifestyle, that it's a pattern. And so the dietary pattern that Jay advocates, of course, he was a cardiac surgeon. So he does advocate for the dietary pattern to stop hypertension, which is essentially the same as the American Heart Association diet. It's not exactly the same, but it's very close. And here's kind of where it boils down. This is kind of feel the pattern compared to the plate in your mind. Grains, and these are specifically, the asterisk is whole grains. And if you're on a 2,000 per day caloric level, that's going to be 6 to 8 servings. But you want to be careful to think about what a serving is. So serving is it's a mixed metaphor sometimes. A serving would be like 1 slice of bread or 1 ounce of dry cereal. Vegetables, 4 to 5 servings per day, where a vegetable is going to be like 1 cup of leafy greens. So 1 cup of leafy greens is not a lot of leafy greens, actually. So you eat a big salad, you're probably getting 3 or 4 servings. Well, if you eat like I do anyway. Or a half a cup of vegetable juice. Fruits, again, another 4 to 5 servings per day. And here we're talking about a medium-sized apple. So not like a Honeycrisp, because the Honeycrisp can be really big. That's 2 servings. So it's more like a Jonathan, where you got an apple the size of maybe a little bigger than my fist. And then fat-free or low-fat milk. 2 to 3 servings a day, where 1 cup of milk or yogurt is 1 serving. So fat-free, this is where yogurt would fall in as well. And then lean meats, poultry, and fish, 6 or less. So 6 servings sounds like a lot, but 1 ounce uncooked is considered a serving. And so if you eat a Big Mac, that's 5 ounces. Well, a Big Mac is 8. That's already 1 Big Mac is more than what the DASH diet is recommending. So that's the pattern that we're recommending. So what do Americans actually consume? So I gave you a kind of a picture. So we can look at the USDA dietary summary. There's another one of these due soon. USDA does not do these very often. This is the graph for consumed refined grain to distinguish from whole grain. So males in the United States are eating way below the standard. This is a little bit wrong. This is whole grain. So whether you're a male age 1 to 3, a male age 1 to 4, that's right, you can't see that. If you're a male age 1 to 3, mid-years, 50 to age 70 or greater than 71, you're eating at roughly 95% or more below the standard for whole grains. And so there's only a few people in the survey eating at or above the recommendation for whole grains. So the standard American diet does, provide carbs, but actually not fiber, because most of the carbs that you get in ultra-processed foods have the fiber stripped out. And so from a grain perspective, essentially when you're making processed food, what you strip out is the endosperm, which is essentially 97% starch. And that's what the product is that's being used. If you get whole grain food, specifically the germ is included and the bran, the kind of the protein-rich shell on the outside of the grain is also included. And so really what we are after is whole grains in the diet, not refined grains. So if we look at vegetables, this is what Americans are consuming in terms of vegetables. If we look at kind of kids, really about 80% are below the recommendation. If you look at the teens, they're quite a bit below the recommendations. As we get older, we tend to eat a few more vegetables. But even in the older side, we're still only eating at 80% below the recommendation. There's hardly anybody eating at or above the recommendation for the amount of vegetables. So what are we getting in vegetables? We're missing out on nutrients, specifically antioxidants. So antioxidants are produced by plants to prevent solar damage from solar radiation. It's essentially working in plants like we would put sunscreen on to protect ourselves from the effect of sunlight. And so it turns out the human body doesn't produce any antioxidants. We have to get them in our diet. And if we don't eat many vegetables, we're missing out on a major source of antioxidants. We're also missing out on minerals and probably most notably fiber. We are also missing out on some quality protein and quality oils. So if we look at fruits, maybe we're doing a little better with fruits than we are with vegetables. So there's the goal with fruits. We another 4 to 5 servings per day. And we do a little better with fruits than we do with veggies. But we're still really, on average, sitting at 70 to 80% below the recommendation for fruits. So what are we getting with fruits? Antioxidants. When you eat fruits of color, the color in fruits is indicative of the antioxidants that are there. The color red in a plant is anthocyanin. It is an antioxidant. The color yellow and orange, those are carotenoids. And these are so when we actually are eating the colors themselves are the antioxidants and minerals, and then again, fiber. If we look at the DASH dietary fruits and vegetables fight the risk of cardiovascular disease. The colors are carrying the antioxidants themselves. Frozen fruits are good ways of getting fruit in the off season. So yeah, we live here in the fruit belt. Fresh fruit is wonderful, kind of like starting now, maybe a little longer for asparagus. But be careful if you get canned vegetables in particular, because almost always there's a significant amount of salt added to canned vegetables. If you use canned vegetables, at the very least, drain all the water off. Because Jay Hallman, in the book, he talks about his first job in the state of Washington, where he grew up, was in a cannery where they were canning vegetables. And his job was to drive the forklift, moving around the 50-pound bags of salt. He was going, what do they use salt for? Turns out there's a lot of salt in canned veggies. So 22% of individuals achieve the 5 servings of fruits and vegetables in the United States. And then if we look at kind of the meat and the dairy side of it, here's the protein, kind of considering both of those. Generally, we get enough protein, is what this graph shows. So there's a percentage of the American population, 40% are below the recommendations for protein, but there's another 40 to 50% above the recommendation for protein. So we get enough protein. Now the question is how we get the protein. If we're getting the protein as red meat, you're picking up salt and saturated fat, which are the primary concerns. Turns out cholesterol, maybe not so much of a concern, although there's a relationship between saturated fat and cholesterol metabolically. If you look at how much saturated fat we consume in the United States, we are 70 to 80% above the USDA recommendation. And so that's consistent with, again, eating the processed foods, which are carrying the vegetable oil rich kind of components in the meat side of our diet. What do we consume in the United States as it relates to seafood? Given the seafood's protective capacity, not near enough, is what this suggests. 80 to 90% of people in the United States, and I would say are teens, the ones that I see at Calvin. If we go on like trips, I'd take students to Cambodia, where they eat almost all the protein that they get is, at least animal-based protein, is fish. American kids do not like fish, and I don't know why not, but they just don't, especially if there are bones involved. So in 2022, the average American ate 224 pounds of meat, 9.8 ounces per day. 6 ounces of that was red. So I'm going to skip through the next couple charts. Basically, well, I'm going to skip. I'm going to go quite fast, though. Daily consumption of sugar. This is added sugar. It does not include the sugar that's already in the fruit or in the vegetable. So the goal per week is 5 tablespoons, that or less. 1 can of 12-ounce sugar pop has got 5 tablespoons of sugar in it. So you eat 1 12-ounce can of pop and you got your weekly allotment of added sugar. My wife worries about the sugar that's in the apple. Don't have to worry about that. That's free. Salt is a major concern of the DASH dietary pattern. Basically, the goal is 2,300 milligrams or a teaspoon of salt, added salt or less per day. So this does not include the salt that's already in meat or already in fruits or vegetables. This is added salt. The risks of getting added salt are generally going to be from processed foods and restaurants. So I want to close because I think we're at the kind of the end of the time here pretty quick. Chronic disease, we can think about phenotype or the risk of disease being a function of genotype and environment. And it turns out, yeah, the risks, an expanded version of this is say the risk of premature death is due in part to behaviors, social circumstances, genetics, access to healthcare, and environmental factors. The genetics component is really important because you are born with your genetic makeup. If all of this risk is due to genetics, you're never going to drive any behavioral change because then you're just a victim of your genetics. The question is, how much of this is due to behaviors, possibly social circumstances, which we could potentially do something about, access to healthcare or environmental factors. And I'm going to skip through that, and kind of what that data kind of all boils down to is to say, risk of premature death is about 40% due to behaviors, which includes smoking, diet, and alcohol. And the biggest component in there is smoking. Smoking is responsible for 20% of that 40% bracket, half of it. Roughly 15% due to maybe social circumstances, access to healthcare, another 10% environmental factors, lead, air quality, that sort of thing. Roughly 30% due to genetics is the estimate. So yeah, there's a degree to which genetic disposition is significant. On the other hand, 2/3 of it is potentially controllable. Key takeaways: adopt a prudent diet, whole foods, plant-based, nutrient-rich, caloric. If you eat basically 8 servings a day of whole grains, 4 or 5 servings of vegetables, 4 or 5 servings of fruit, eat whatever else you can. You're going to be plenty full with that. It will be a diet that is nutritionally rich and calorically poor. The goal of the DASH diet is not to lose weight, but people who go on it typically will lose weight because of that. Train physicians on nutrition as a frontline intervention. We've got a fun paper I could share with you at some point in time if you're interested, kind of about that, but it turns out most people who go through medical school do not get any, well, very little, if any, nutritional training, which is just frustrating, maybe. He might have, or he understood. And actually, Jay starts out one of the chapters in the book by saying, even as a young cardiac surgeon, he went to conferences and he was watching what the surgeons he was working with were eating, and he would eat that. That's what got him started. So watch what your doctor eats. And you're probably not going to be too far off. Just a couple of quick thoughts to leave you with. Let's put this in a faith-based context. 1 Corinthians 6:12. I have the right to do anything you say, but not everything is beneficial. The food's in the grocery store. Should we eat it? 1 Corinthians 6:19-20, a little later in that same chapter, our bodies are temples and should be cherished and taken care of as the Spirit of God resides in us. So therein lies some of that responsibility of what we should do with our bodies. Mark 2:5, when Jesus saw their faith, he told the paralytic, son, your sins are forgiven. If Jesus saw someone with coronary heart disease, would he say your vascular disease is healed, or would he say your sins are forgiven? Look back at how Jesus healed. You'll be surprised. I would, at least I have been. John 9:1-3, a man blind from birth, Jesus answered, neither this man nor his parents sinned. He was born blind so that God's works might be revealed in him. So yeah, I mean, it is in our humanity at times to be sick. John 3:13-5, Jesus served us because of his love for us. How should we respond to Jesus? All right. Questions? Or I know we're kind of at the end of the time, but.
A quick one. When they put fish on one of those charts, are they lumping all the seafood in under that term?
They did.
Okay.
Yeah, they did.
So are some fish more healthier than others, like higher omega-3s and such?
Yeah, I think there's pretty good evidence that that's true. So anything in the salmonoid family,
Mhm.
which is also kind of a stronger tasting fish, so trout and
What about
salmon.
farm versus wild?
The jury is a little bit out on that one. So farm fish are basically fed corn and soybean and maybe fish meal or fish processing byproduct. The evidence in terms of the fish, its impact on our health is that there's not much difference, if any at all. But the impact on the environmental health is significant. So farming fish is not necessarily good for the environment.
So we should just fish all the fish in the ocean out of
Well,
existence?
that's the other side. If we can overfish too. So I'm not sure what the best solution there is.
Anyone else?
Eat down on the fish chain, but then you lose the salmonoid advantage because they're apex predators, right? They're way up high on the trophic level.
Any more questions? Well, I think it's quitting time, so we'll look forward to seeing you next week. Same place, same time.
Yep.
And I think the topic is going to be about, I'll have to look this up.
It's going to be essentially the impact of our
Yeah,
food
session
production
2.
systems on environmental health.
Yeah. Explain how our current food system affects environmental health.
Yeah, so I worked for 20, including grad school, 25 years in industrialized ag systems. So we're going to talk
Okay.
about that. We're going to talk
All
about
right.
how things came to
Good.
be what they are and maybe what the concerns are. And maybe there are some concerns out there that I think probably are not, they don't need to be concerns, but there are lots of concerns. So
Sure.
I'm going to make you feel bad. Sorry.
Okay, look forward to it. Thank you.
I got to figure out how to work this thing better. No kidding.
Get more sustainable.
Yeah, exactly. Well, that's.